Hello, in this video we are going to review fraction concepts that you have previously learned, but it is really important that we are able to recall this information and apply it to the new information that you will be learning about fractions in 5th grade. The first thing I want to show you is our fraction strips or fraction tiles. All of you have this at home in your math folders, and I encourage you to have this nearby throughout our fraction unit. Use the fraction strips to help you, especially when you're identifying fractions or determining the value of that fraction. Seeing it visually is extremely helpful as well. And you are also welcome to use the fraction strips at any time during this video or during any classwork. Just as a reminder, here we have the fraction 3/5. And notice I drew this here, and in fact I shaded in the 3 pieces of the whole, 5 pieces representing my fraction. Now 3 was represented as my numerator, which is the part of the whole, and my denominator is 5, which is the whole. So here, notice what's shaded in is I have 3 out of the 5 pieces are shaded. Now I determine my denominator as my whole because here's my whole circle, and this circle is broken into 5 equal pieces. Now since the whole circle is not fully shaded in, that's where my fraction comes into play. And my fraction here of 3/5 is less than a whole, and in fact that 3/5 is a piece of the whole, which represents my fraction. Here I also have 3/5 one more time, but I also have 9/15. Now I notice these two fractions have different numerators and different denominators. However, in my picture, the same amount is shaded in. That's because 3/5 and 9/15 are equivalent. They are equivalent fractions, which means that they are equal. Even though there is different numbers as my numerator and denominator, the value of each of these fractions and the size are exactly the same, which means that they are equal. And we can prove this because if I look at my denominators, we have 5 and 15. Well, 5 times 3 happens to be 15. And I notice if I also do 3 times 3, that happens to be 9, which if I put the 9 and the 15 together, I create my fraction of 9/15, which is showing that these two fractions are equivalent, as the picture also proves that as well. When you are dealing with equivalent fractions and you're finding or discovering other fractions that could be equivalent, you can multiply or divide both your numerator and denominator by the same number to create that equivalent fraction. So in this problem, I took 3/5 and I multiplied my numerator by 3 and my denominator by 3 to give me an equivalent fraction, and to figure out what could be equivalent is 9/15. Now you could choose 5, you could choose 6, you could choose any number you would like, but whatever number you select, make sure you multiply the numerator and the denominator by that number. And in this example here, we have 2/3 equals some number 12ths. So we need to figure out, well, we have 12ths here. So I wonder what 12ths represents 2/3. So let's see. You can choose to look at your fraction strips and go down the line, find 2/3 and see, well, let's take a look at my 12ths. How many 12ths do I need to be equivalent or equal to 2/3? Or you can also look at where you have both information that's given to you. So if I look at my denominator here, I have 3 and I have 12. Well, 3 times some number is 12, so 3 times 4 is 12. And we learned that if you multiply your denominator by 4, you have to also multiply your numerator by 4. So 2 times 4 happens to be 8, giving me a fraction of 8/12, which is in fact equivalent to 2/3. And if you look at your fraction strips and you look at 2/3 and you look at 8/12, you're going to see that they're exactly the same size, which is telling you that they are both equivalent or equal to one another. In this problem here, we have 1/4 and we have 7/8. Your goal is to select, is it is 1/4 greater, less than, or equal to 7/8. So you're ultimately comparing these two fractions. Now there's many ways that you can do this. The first way is you can take a look at your fraction strips. You can find 1/4, you can find 7/8, and you will recognize that 7/8 is significantly larger than 1/4. You might also recognize by looking at your fraction strips that 7/8 is very close to 1, and 1/4 is much closer to 0. So if you want to use 0, 1/2, and 1 as benchmarks here, just to help you compare and decide, well, is it closer to 0, closer to 1, to help you determine which one's larger or smaller, you're welcome to do that as well. And by using those benchmarks, well, 7/8 is much closer to 1, and 1/4 is closer to 0. So clearly 7/8 is larger. Those are two great ways to take a look at this. You can also choose to draw a picture if you would like. That's absolutely fine. Another way is also my equivalent fraction method. So my equivalent fraction method here is going to create two new fractions. But the only difference here is that these two fractions are going to have the same denominator. Now you might right away recognize, well, 1/4 is actually the same as 2/8. And you might see that that's a great thing to take a look at, because now 7/8 and 2/8 have the same denominator. So instead of writing 1/4, I can write 2/8, and I can keep my 7/8. And now, since they have the same denominator, all you have to do is take a look at your numerators. And you see that 2/8 happens to be less than 7/8. So here in this problem, you would choose 2/8 is less than 7/8. You can also choose to use the equivalent fraction method. Maybe you didn't pick up on that right away. So the first thing I'm going to do here is, let's change this color so we can see it a little bit better. I'm going to first multiply what is across from one another. 1 times 8, which happens to be 8. And 7 times 4, which happens to be 28. But notice here we only have my numerators. Now I need to figure out my denominator. And I'm going to take my two denominators here, which happens to be 4 and 8, and multiply them. 4 times 8 is 32, giving me a new fraction of 8/32. And 8 times 4 happens to be 32 again here, giving me a new fraction of 38/22. Now let's rewrite this, and now we're going to compare 8/32, because I'm replacing 8/32 with 1/4 because we show that they're equivalent or equal to one another. And I'm replacing 7/8 with 28/32. And notice as I look at my numerators, 8 is less than 28. Therefore, 8/32 is less than 28/32. So by using the equivalent fraction method, you are creating new fractions. But before you compare, you are changing those two fractions and finding an equivalent fraction for both of them that will now have the same denominator, which makes it really simple when we're comparing, because once they're the same denominator, you can simply look at your numerators. Now, using the other methods are great as well, and sometimes you might not always use those equivalent fraction methods, but if you're stuck at any point, you can always use that to help you. Because notice here my numbers were much larger doing it this way than doing it this way, or drawing a picture, or using my fraction strips, or using benchmarks to help. But you choose what works best for you. Now we're going to move on to improper fractions and mixed numbers here. So I have a picture given. I see that there's two fully shaded circles, and there's a third one, but it's not fully shaded in. This means that I have a mixed number or an improper fraction that is used to represent a number when it's greater than 1. So notice we don't just have one circle in this problem anymore. We have 3 circles, and I found that 2 of them were fully shaded in. So we have 2 holes, But now my third one, I don't have a full circle. So I look here and I see that, well, 3 pieces are shaded in, and I notice that every single circle is broken into 4 equal pieces, which is telling me my denominator is going to be 4. So to represent this picture as a mixed number, you can represent it as 2 and 3/4. Now you can also represent this as an improper fraction. And you can do that by counting how many 1/4 you have. So let's see. We have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4, 10/4, and 11/4. And that's showing me that 11/4 is equivalent or equal to 2 and 3/4. Sometimes people like representing your numbers as a mixed number, which has a mix of a whole number and a proper fraction. Or you like representing it as an improper fraction, which looks a little bit different than what we're used to because my numerator is larger than my denominator. And those are characteristics of an improper fraction. Now, having these pictures available are wonderful to use to help you determine how to represent something as a mixed number or an improper fraction. Many of you might also recognize a little quick trick, which happens to be to take your denominator and 4 times 2, take your denominator and multiply by your whole number, which is 8, and then add your numerator is 11. And notice we have the same denominator because we didn't change the way or the size of each of these individual pieces, no matter if we represented it as an improper fraction or a mixed number. And we're going to try this one real quick. We have 4 pieces here. I found that only 3 are fully shaded in. And I recognize that this one piece here that is not fully shaded in, this rectangle here, there are 2 pieces shaded in. And I see that every single one of these rectangles is broken into 3 equal pieces, which is representing my denominator. Now, every mixed number can be represented as an improper fraction. Every improper fraction can be represented as a mixed number. So now we have thirds. Let's see how many thirds we have. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 thirds. And that's showing me that 11 thirds is exactly the same as 3 and 2/3. And here we have adding fractions. Notice here in all 3 of these pictures, everything is broken into fifths. Each piece is exactly the same size. We have fifths, fifths, and fifths. And notice when we're adding fractions, all we are doing is combining our numerators. And the pictures is a great example of it. I'm taking this one piece here that's shaded in, and this 2 pieces here are 2/5. Notice we have 1/5 and 1/5 and 1/5, and we combine them together, creating 3/5. Whenever I'm adding or subtracting fractions, your denominators need to be the same first. Here they were already 5. And the same goes for when you're subtracting. In this picture, we have fourths. We have 3/4 minus 2/4, which happens to be 1/4. And finally, we have a problem when my denominators are not the same. This is where equivalent fractions come into play. I notice that we have 3/10 and 26/100. Now you can also represent 3/10 as a decimal as 3/10. And we know that 3/10 is the same thing as 30/100, which we can also write this as 30/100. And if you were to have a picture of a hundredths grid, a rectangle with 100 little pieces, you're going to find that you shade in 30 of those pieces, which is also the same as if you change that 100 grid to 10 pieces, is the same as having 3 of those pieces shaded as well. And we can prove that this continues to be equivalent because if I look at 3/10 and I multiply my denominator by 10 and I multiply my numerator by 10, now my new problem becomes 30/100 plus 26/100. And now I can simply just add my numerators together, which is going to give me an answer of 56/100. But notice before I added these two fractions, I wanted to make sure that my denominators are exactly the same before you add or subtract. And on this note, this is what we're going to continue working on in 5th grade. In 4th grade, you explored when your denominator was 10 or 100. Now we're going to begin to explore when it's other digits, such as 5 or 7 or 12, all different numbers, and what and how you can apply equivalent fractions to help you add and subtract fractions.